Good morning, class. We are still waiting because couple of more students are still keep joining us. So in the meantime, please note my email ID and the mobile number so that you can have a distant communication throughout available with me. Okay, students, let us start. Good morning. I am Dr. Bhupendra Kumar Churasama. I am Associate Professor in School of Physics and Material Science. I will going to conduct your lecture classes for the subject UES 012 Engineering Materials. Please note down, this is the Google web page for the subject. While we are migrating to a new page, which is the LMS, before we complete the migration, most of the literature relevant to this subject is available on this particular Google page. So you can refer this Google page as well. On this particular page, you will have literature pertaining to the syllabus of the subject, the evaluation scheme which we will typically follow. I will going to discuss both this aspect in a while from now in this particular class. All the tutorial sheets are also available on this page. The lab manuals are available and couple of question papers pertaining to previous examinations are also uploaded on this particular page along with the answer keys for the latest previous examination. You can also find the contact details of group wise tutors and lab instructors on this particular page. Although we are in the process of updating this, so the contact details will be available to you in couple of days time, maybe within this weekend. Okay, generally your first and the foremost query in the first lecture is what will be the evaluation scheme for this particular subject. So as you people are aware that we always have a 100-mark evaluation, which is generally being divided into three components: the mid-semester examination, the end-semester examination, and couple of subsections in the form of sessionals. So in this subject also, we will have the same pattern. Typically, the mid-semester test is for 25 marks, the end semester test is for 35 marks, and remaining 40 number goes for the sessional, which is again subdivided into lab evaluation, which is for 25 marks, tutorial test, which will be for 5 marks, and there will be a dedicated quiz, which will be for 10 marks. As we are under an unusual circumstances where we have a online teaching through a distant mode, uh, we are not sure, depending on the circumstances, when the mid-semester test and end semester will be conducted, and if it all conducted. This will be the pattern of evaluation. If any changes is being forced upon us due to the prevailing circumstances, then I will get back to you as far as the evaluation is concerned. But at this moment, we will stick to the standard evaluation pattern, which will comprise of the mid-semester test, end semester test, and the sessionals. So you can note this down. These are also available on the web page, which I have just discussed. Okay, now coming to the syllabus of the course. As you people are aware that this particular course has 4.5 credits. So it has 3 lectures per week, 1 tutorial per week, and 1 lab session per week. Tutorial and lab, as you people are aware, we will do it in a group-wise manner, while all the lecture classes I will going to conduct. There will be 3 lectures per week. Now, before we go into the minute detail of the syllabus, the first obvious question which every student has in their mind is, what is the objective behind studying this course? As you people are aware that this is a core course, and every student of engineering, irrespective of his or her branch, takes up this course. So why this course is so critical? What is the objective behind learning this course? You people are aware that irrespective of the branch, engineers requires material, and materials with diverse properties. So while designing an engineering project, as a design engineer, you should be able to select material with appropriate required qualities in it. So how do you decide which material best suit to your engineering problem? So to answer this, you should possess knowledge vis-a-vis to the characteristic of the material and understanding of the material's behavior under given circumstances. For example, if you need a metal which is subjected to, let us say, 10 Newton pressure, then what metal is appropriate for that kind of pressure? Or the metal is subject to, let's say, 2000 degrees centigrade, then what kind of material will be appropriate for that kind of application? You should be able to identify by yourself. Likewise, let's say if you are a chemical engineer, then you should look into the chemical reactivity of the material. If you are electrical engineer, you should be able to decide based on either the electrical conductivity or the transport properties of the material or the semiconducting behavior of the material, and so on and so forth. So at a later stage, we will go into these diverse classes and what properties will decide which particular characteristic of the material. We will going to study those things in detail. Broadly, the primary objective of this course is to introduce you people with the concept of engineering materials, and the process of studying this subject will be, we will try to correlate the properties of the material vis-a-vis to its internal structure. Because if you know the internal structure of the material, you can predict the properties, and if you can predict the properties, you can utilize an engineering material in your design problem in a more appropriate and efficient manner. So I repeat, throughout this course, we will keep coming back to the idea of correlating structure with the property of the material. So primary objective of this course is to make a correlation between the structure of the material and the property of the material. Which materials? Not all the materials that exist in the universe. We will focus only on engineering materials. So, as I explained, structure will be one of the most important aspect of our discussion throughout this syllabus. So we will begin our discussion with the understanding of the structures of the solid, and that will going to make our first unit. We will first classify the engineering materials into couple of subgroups, and our process will be, we will not study engineering materials as independent examples, rather than we will study them in groups. For example, one particular group of magnetic materials. So we will not talk about iron oxide or nickel chloride or cobalt ferrite or specific examples like that. Rather than we will study the entire group of magnetic materials in one subsection. Likewise, there will be another subsection of insulating materials or maybe semiconducting materials or materials with elastic behavior, materials which are corrosion resistant. So we will define them in subgroups and then we will study them. The objective in studying this structure is to correlate structure with the subsequent properties which you will achieve from that particular structure. So rather than looking at individual material structure, we will talk about the basic classes of these structures and how the property depends on those structures. That will be the primary goal of our discussion. Now, what kind of structure that we will refer here? In your primary school days, you have learned couple of structures of the material. For example, crystal structure you are aware about. So we will going to study crystal structure of the solid in a more detailed manner, how one can define them, how one can actually experimentally measure the crystal structure, and analyzing the internal structure of the material to predict its properties. Then we will talk about the inorganic class and the organic class of the materials. Again, when I say inorganic class and the organic class, it is very vast. We will not focus all of them, but our focus will remain only on those solids which is important from the engineering perspective. Then we will discuss the defects in the solids, because you know that any engineering application is always under a diverse degree of stress. For example, if there is a dam site or a boiler, it is always under different degree of stress. So sometimes stress could lead to a failure. So you should be able to predict the life of the product as well under the given circumstances. And while doing so, you should acquire the knowledge of defects that could emerge or which are already present in the material. So we will also study defects which could be present in the solid or which could emerge in the solid under different circumstances at a later stage. Once you are through with the understanding of the internal structure of the solid and start predicting the properties of the material, then we will discuss different properties of the material pertaining to different categories of their application. In this, we will discuss the first aspect, which is the mechanical properties of the material. So in this particular unit, we will going to discuss those properties of the material which is more important vis-a-vis to the mechanical properties of the material. Here we will going to study first the elastic behavior of the material, followed by an inelastic and viscoelastic behavior. At this point, if you are not able to understand these terms, it will be perfectly fine, because we will going to study them in quite a detail at a later stage. Then we will make a correlation between engineering stress and engineering strain, because as far as the mechanical property of the material is concerned, the understanding of the applied stress and its impact on the engineering material vis-a-vis to the developed strain is most important. So if you can understand how stress affect the strain in the material, you will be able to predict the mechanical failures in the material. Then we will follow to true stress versus true strain relationship. There is a little difference vis-a-vis to the concept between the engineering stress strain and true stress strain. So what exactly it is, it will be clear to you when we will discuss them in detail. But for a time being, what you should understand is the primary approach of studying the mechanical properties will be how stress affects the strain of the material. Then we will review couple of important physical quantities that defines mechanical properties, like how you can harden the material. Then we will talk about various ways by which the deformation in the solid happens, because if you can understand the mechanism leading to the deformation in the solid, you can devise ways to stop those deformation, and in this way you can prevent the failure of the engineering system. In this category, we will talk about the plastic deformation, its mechanism by twinning and slip. What is twinning, what is slip? We will come back to it at a later stage. There is something called dislocation movement, which is also very critical, leading to the deformation in solid. Dislocation is basically kind of a defect which under an applied load moves within the crystal, that if unaltered can lead to the deformation in the solid. So we'll discuss those aspects. Then there is something called critical shear stress. This is the critical value, and if you can cross this limit, it can lead to the disintegration of the solid. So how one can measure the critical shear stress and how you can always maintain your engineering system below this critical value, those things we will discuss here. At last, we will talk about the strengthening mechanism, how you actually improve the mechanical properties vis-a-vis to its strength can be altered. Those aspects in designing the material and processing the material we will discuss here. In the next unit, which makes our unit number 3, the unit is called the equilibrium diagram. In this particular unit, we will going to study couple of charts. Basically, in this unit, I will going to teach you how to read charts, which is basically a complex graphs. If you can able to read those graphs, you will be able to predict the material's behavior at different temperature and pressure, which are the most critical parameters in any engineering system. So in this particular unit, mainly we will understand how to read Those graphs, in technical terms, they are called equilibrium phase diagrams of the material. So for every material, such diagrams are available. They are like standard logarithmic table. So like logarithmic table, you have equilibrium phase diagram for every material available in a standard literature. We will learn how to read them, and once you understand how to read them, we will use them for designing and predicting the structure and property correlation between the material. In this discussion, we will first learn couple of basic principles of the thermodynamics of the solids. You might have learned this in your primary school days, but we need a detailed understanding of it. So we'll review them quickly, and then we will implement that understanding in defining the phase diagrams. There will be two types of phase diagrams that will be the focus of discussion. One is called unary, the other one is called binary. Unary, as the meaning says, it will be a single component system, and binary, that means it will be a two component system. We will take also couple of representative example problems here, where you can actually take a phase diagram to design a particular characteristic of the material. So those aspects we will learn in this particular unit. Subsequent to this, we will move to the next unit, which is unit number 4, and this unit will deal with the electrical and magnetic properties of the material. So when you say electrical property, again there will be 3 subclasses: the conducting properties, the semiconducting properties, and the insulating properties. Again, our focus will be how structure makes one material conducting while the other material insulating or semiconducting. That will be the focus of our discussion. Then we talk about the dielectric properties of the material, which is basically a subclass of a insulating materials. We will also going to study superconductors as a special class of the material belonging to the conducting class, and then we will discuss couple of properties with relevant examples vis-a-vis to the magnetic properties of the material. Subsequent to this, we have the 5th unit, which is corrosion. Corrosion is basically a universal phenomena and impart a major cost on industry because of the process of corrosion. So as an engineer, we must understand the process of corrosion, and we should also devise means by which you can at least minimize the rate of corrosion, because you will study this that corrosion cannot be stopped 100%. So it will always keep going on. But as a design engineer, we should use materials which corrode least under given environment. So we will study a couple of basic mechanisms leading to the corrosion and how you can alter them, minimize their rate of corrosion. That will be the focus of discussion. Although this is the second last unit, but we will cover it as unit number 2. So after the structure of the solids, we will cover this unit. The final unit, which is the material selection, in this particular unit, the aim is to select appropriate engineering material for a given design problem. We will not going to study this unit individually, rather than we will cover this unit in different subunits which I have already discussed, like mechanical properties, phase diagram, electrical, magnetic, superconducting and dielectric properties, as well as the corrosion. So relevant selection criteria pertaining to those particular applications, we will discuss those aspects in that particular subunit, and the last unit we will not going to study as an independent unit. So my point is, the final unit, relevant topics we will cover with relevant units. So once you are through with all these 6 units in this particular course, you should be able to classify engineering materials based on structure. So as I explained, we will not going to study individual materials, but we will study materials in different classes. So you should be able to classify materials based on their structure. The second objective is, once you are studying the crystal structure of the material, you should be able to draw crystallographic planes and its direction, because to predict the crystal structure, the knowledge of crystallographic planes and its direction is a very important concept, and you should be able to do this. The third outcome will be, once you study the mechanical properties of the material, you should be able to discriminate two broader classes, that is elastic and plastic classes of the material. You should be able to distinguish amongst them. Once you study the phase diagram, you will be able to distinguish the two broad classes of the phase diagram. One is called isomorphous, which will have only one phase diagram in entire temperature and pressure region, and the other class is called eutectic phase diagram, which has multiple subsections in the entire temperature and pressure region. So how isomorphous is different from eutectic, you will be able to tell that, and how they will going to behave differently at given pressure and temperature, you should be able to predict those things once we cover the unit on the equilibrium phase diagram. Once you study the electrical and magnetic properties of the material, you will be able to classify engineering materials vis-a-vis to their electrical properties and vis-a-vis to their magnetic properties. So there will be subclasses of electrical properties, there will be subclasses of the magnetic properties. You will be able to classify any material into those relevant subcategories based on the structure, and since the structure is now known to you, you will also be able to predict the properties which you will achieve from those materials. At last, once you understand the process of corrosion, you will be able to provide engineering solutions to prevent corrosion in the solid. So these are the 6 outcomes pertaining to 6 units. Now coming to the books. These are the listed books in our syllabus. We have 3 textbooks. The first one is Material Science and Engineering by W.D. Callister. The second one is Principle of Material Science and Engineering by W.F. Smith. And the third one is Introduction to Material Science and Engineering by V. Raghavan. Most of our syllabus we will going to cover from the book number 3, that is book written by V. Raghavan. This book is relatively simple, written by an Indian author. So level of English language is also at the mid level, and most of the students can grasp it very easily. In addition to that, all the topics are provided in this particular book in a very crisp manner. Although Callister and Smith is equally good book, but since it is being written by foreign authors, the level of English language is on a little higher side, and many students find it difficult to grasp the concept from this book. But if you are fine with it, you can still use the Callister and Smith. Personally, my favorite book is the Callister's book, so you can also refer it. But my personal advice to the students is you follow the Raghuvan's book. Uh, throughout the discussion, I will keep referring which book I am using for that particular topic. Wherever I am changing the book, I will let you know, and accordingly you can follow. If you purchase V. Raghavan's book, you will be able to cover at least 90% of your topics, which we will going to discuss in this syllabus. Apart from these 3 textbooks, we have 3 reference books. One is by S.O. Kasab, second one is L.H. Van Black, and third one is K.G. Budinsky. Lot of practice problems are available in S.O. Kasab's book. So if you find that your tutorial sheets are not sufficient enough and you want more practice problem, you can refer S.O. Kasab's book. The Smith's book, which is the second in the textbook category, is also the book which contains lot of practice problems. Of course, Raghavan's book do possess problems pertaining to the tutorial problems. So if you find any interviewing problem in these books which you are not able to solve it, then you can always refer it back to me. I hope I have tried to answer most of your queries vis-a-vis to this particular course. The way we will going to approach it. Still, if you are left with any other queries, you can send me a text message. You can raise your queries here as a chat message. I will be happy to answer them since we have very limited time left now. So if there are any queries in couple of minutes, I will be able to answer them. I will try to do it now. Else, I will cover those queries in the tomorrow's lecture. Before we close our today's discussion, I want to make a request to you people. Since today was the first day, so I allow students to enter irrelevant of the time. But if you keep coming at different times, then it will be distracting for me because I have to always allow you to enter into the room. So what we will do from tomorrow onwards is after the 5 minutes of the scheduled time, I will lock the session. So whosoever is in will be inside, and whosoever are left, I will not allow them to enter after the 5 minutes of the scheduled lecture time. So please be there on time so that we do not lose our important discussion time. As far as the web link of the Google page is concerned, I will share that particular link with you. There is another query. If any student has unstable internet connectivity, and because of that, if you have missed some portion of the discussion, you need not to worry, because we will going to upload the recorded lectures on the LMS page. We also are in the process of preparing the pre-recorded video lectures. We will also going to upload them on LMS server. So you will have both the the pre-recorded version and the current version available on the website. So you can always go to the web page and go through those videos at ease at your convenience. Next is vis-a-vis to the attendance. Attendance, you need not to mark. Whosoever has login into this particular room, their attendance will be marked at the back end by the server. So you make sure that you always use your official Thapar ID, email ID for the login purpose, so that your attendance will be marked automatically. As far as the PDF of the books are concerned, I will check on that. If the e-copies are available, I will be happy to share with them. I guess we are through with the current queries. One more message. Many of you might have your tutorials and lectures, tutorials and lab classes, which is being taken by the TAs. Since we are in the process of providing them the relevant logins, your tutorial and labs may not be happening at this moment. I will let you know in tomorrow's class when the tutorials will be covered by the TAs. For the time being, teachers will going to cover your lab and tutorial, but if a particular group has a TA assigned for lab or tutorial, it will be covered in couple of days time. I will get back to you on this at a later stage in tomorrow's class. I think this is all from my side for now. You just visit the Google web page. I am forwarding you the link, and just scroll through the various subgroups there. We will have a more detailed discussion from tomorrow onwards vis-a-vis to this subject. I wish you happy learning. Stay indoors, stay safe, take all necessary precautions. Thank you.